Hello there, fellow classmates, and here I am to present my Parabola project. Today I decided to do it in Minecraft using a TNT cannon. Here is a quick demo of what it should look like. So here is how the cannon works. I press this button, it sends a redstone signal down here, it splits off, and then these repeaters here have a 3-second delay, and then it goes all the way around up to here and sends a signal to this dispenser and activates it, and it shoots off some TNT. And then the one that doesn't split off has no delay, and it goes to the 4 dispensers in the back. They also dispense some TNT that will then explode before the one in here, thus giving the one in the front momentum and shoots it across the axis? I don't know. So I decided to make my grid here because that's where the vertex is. So 0, 0 is one block underneath the launching point, because if I put it there I would have had to put a block here, which then might have disrupted the parabola of the launch. So I put it one down, which means that the launch point is at 13, 1. The vertex is again on the y-axis, which would then make it 0, 6, and the landing point is at negative 13, 1. It usually lands where this glowstone is, right where that water is. But if it were on the 0, it would have landed on negative 14 roughly. It actually was a little bit further than that, but I never knew exactly how much further. But it'll show you on the graph, just to make sure that you get an idea of what the TNT looks like in midair. Boom. Another thing I forgot to mention is each block is 1 point on the grid. So if you were to be on this block, that'd be 1, 2, 3, so on and so forth. Now let's look at the math behind the launch. So I decided to do all of this work. Here is all my points. Well, here are all my points. 13, 1, 0, 6, and negative 13, 1. I had to put it into the equation of y equals ax plus bx plus, ax squared plus bx plus c. So the first equation ended up being 1 equals 169a plus 13b plus c. The second one was 6 equals c, and then 1 equals 169a minus 13b. So I decided to do elimination since I already knew what c was. So for the first equation, I got 1 equals 169a plus 13b plus 6. I minus 6 from both sides, ending up with negative 5 equals 169a plus 13b. I did the same thing for the other equation of 1 equals 169a minus 13b plus 6. And I got negative 5 equals 169a plus 13b. So for both those equations, I put them on top of each other and saw that the 13b's canceled each other out, which left negative 5 equals 169a. Divided each side by 169, a ended up being negative 5 over 169. I plugged it back into the original equation of 1 equals 169a plus 13b plus c, and it came out as 1 equals 169 times negative 5 over 169 plus 13b plus 6, which gave me 1 equals negative 5 plus 13b plus 6, which over here, because of how the sheet works, I couldn't put like plus 5 on there, so I just did negative 6 plus 5 equals negative 1. So then it showed what it would be on here. I put this just for consistency. So it made 13b equals 0, so b equals 0. Now I have all my points, a equaling -5 over 169, c equals 6, and b equals 0. Plugged it into the original equations, so that then I could check it. 1 equals 169 over, times -5 over 169 plus 13 times 0 plus 6 equals 1, would make 1 equals -5 plus 6, which would make 1 equal 1. 6 equals c would be 6 equals 6. 1 equals 169 times -5 over 169 times -13 times 0 minus 6, which would mean 1 equals -5 plus 6, which would make 1 equal 1. So plugging all those points back into the original equation of y equals ax squared plus bx plus c made the equation of -5 divided by, -5 over 169x squared plus 6. Now before I show you what it looks like on a graph, I'm going to tell you the domain and the range. The domain is -13 over, -13, 0, 13. The domain is the distance that the TNT can travel relative to the x-axis, so like the distance. And the range is 1, 6. It is the height that the TNT can travel relative to the y-axis. Now, you may be asking why I only have a 1 and a 6 there. That's because for both domain and range, if you have multiple of anything, you can only put one of it. As you can see, there's multiple ones. So, I can only put one of the ones there to represent both of them. The vertex was 0, 6. It represents how high the TNT can travel. The line of symmetry is x equals 0. That shows the point where it has the most potential. Well, yeah, where it has the most energy on the point. It also shows where it had the most potential energy, and like whenever it was going up, that's potential. And whenever it's going down, that's it losing energy. The x-intercepts were -14.241 and 14.241. As you can see, I didn't do any work to solve for x being 0 anywhere, so that's because I did it in Desmos. As you can see my equation right here. Y equals -5 over 169 x squared plus 6. You can see my original points of 0, 6, 13, 1 if I just scroll in a little bit. Well, 13, 1 and -13, 1. And there is my x-intercepts of -14.241, 0 and 14.241, 0. Now you may be asking yourself, what does it look like compared to the Minecraft version? Just let me try and compare it. No guarantees here, because you're comparing a 2D landscape to a 3-dimensional one. It might not end up looking anywhere close. Let me just fix how that looks. Now let's try and get that to be on point there. No, that's still not on point. What I'm trying to do is line up the obsidian pillar with the original thing. Now, before I do that, I can draw lines with my thing. So let me just quickly try and draw a line right there and right there. Those are roughly the same, right? Okay, back to game. As you can see, it roughly follows the line. Now you also have to put in that this is a 3-dimensional one, and you can get different angles like this, 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 or even this, which can distort the image. So you can't really know if it's exactly that, but you can get a pretty close idea of it being the same. Now, if that's going to be all for today, I bid you a farewell, and do enjoy the rest of your school day.